Welcome back to more Project XMC. Gonna be doing things with these boosters, and I got a drill bit too. Look at that. Alright, so what's the agenda for today, right? I mean, what are we doing? Well, we are working on these venturi boosters. We're optimizing the design. So let me show you that right now. Okay, so what I've decided is, this is just our test. This is the prototype, right? We have 4, barrels here that we can test in. We already siliconed this guy in place. Not that I couldn't get him out, but already siliconed him in place. That's our starting point. So now we're going to work on an improvement here. Improving this. Now, you guys got to realize something with this right here, right? This is by far the most, how do I say it? This is the least effective design that we could possibly do to this. Like, I am already 37 steps ahead of this design for the actual final one. We are merely testing aspects, how things react. I already know, what the final product is essentially going to look like. I'm just reaffirming, the best I can here with the tools I got and recreating what I actually want in there. Okay, so just realize we're not starting out with this. This is already outdated compared to what, I have in mind. But we're just optimizing this just to prove to myself that what I think I have in mind actually works. Does that make sense? Any hoozle. So what are we doing? We are going to work with the actual atomization and dispensal. Dispensal? Is that a word? Rolling with it. Dispensal. Dispense. Of the fuel, okay? Dispersal. See, I got it eventually. It's just, hours after the fact, right? Continue on. Now, what makes this design terrible are a few things. Namely the fact that the holes are just completely they're on the wall there. See? Now, that works, but it's by far the least optimal design to be effective. Really, you would want the holes to be, essentially shrouded from the incoming air. That way, the air itself is not hindering the fuel from coming out of the holes. And there's other things to it, which one of them we're going to address right now by adding, where'd it go? There it is. By adding that, just like this. Now, what is this setup exactly accomplishing here? It basically just looks like it's just restricting the actual airflow going in. So what's the big deal? Well, if you look at the original design here, so you can see, it's kind of hard to tell because they're 2 different shades of color, but this is pretty much flush. Actually, this has just the slightest lip on it underneath, but essentially it's flush. So what happens is, as the fuel kind of comes out of here, any fuel that's not immediately atomized sticks to the walls of the actual bore itself, right? And that's, well, not entirely, a deal breaker. By far not ideal. You'd want the fuel to be, atomized in the air, not sticking to the walls, like this is here. Again, okay, final product, I already know exactly what this is going to be, and it's going to completely fix it. But for this right here, just to demonstrate and prove, my point here, I want to test out this setup right here. Not exactly like this. We're going to modify this just a bit. But essentially, we are making a ledge for the fuel to come out of, to pile up on that ledge, and then get sheared off of this ledge into the air. atomizing. See what I mean? I want a place for the fuel to go, a place for the fuel to build up, and then shear down into the booster. Right? See what I'm saying? It'll all make sense in a minute, trust me. Okay. But we got to modify this up a little bit. This is just ever so slightly, just a hair bigger circumference than the actual booster itself, meaning it's not fitting down into our, carburetor here. Also, I don't know for a fact, but I have a suspicion once we stack that there, okay, kind of hard to see, once we stack that there, that is raising the whole booster up, so our engagement in this cut channel might be a little bit compromised. We can always JB weld our silicone around the outside of it to seal it up. But just something we gotta keep in mind. Also, not only do we have to shrink the outside diameter of this a bit, we need to contour the inside diameter. I don't want it flat. I want it to be coned. I want to push this inside diameter, that way it's not just flat like this. It's actually kind of tapering down into the bore. See what I mean? Like a ramp for the fuel to flow down and then get sheared off. Is this going to affect the overall flow of it? Well, yeah, but you got to keep in mind, we used a really small carburetor. This is a 650 carburetor. I mean, if the design of the booster constricts the opening, you just make the opening a little bit bigger. That's fine. The overall CFM of the carburetor, we're not concerned with at all at this point. Simply the function of the booster is all we're testing. First things first, let's shrink the outside diameter of this bad boy just a little bit. And we don't need much, just enough to fit in that groove we made in the carburetor. And there is a very fast, easy, and effective way to go about doing this. And by fast, I mean, just construct this giant conglomerate to accomplish the job. That's what I meant. Just like that, she now fits. On to step 2. Step 2 is going to be the challenging part, because sifting through all that to come up with that contraption was the easy part. We have to now figure out a way to taper, I guess taper might be a word for it. We have to taper the inside diameter down whilst keeping the outside diameter true to seal against that ledge there. Oh, just so you know, if you're wondering if this is the right way to use these tools, no, it's not. But might possibly work. Yeah. Yep. That might work. Let's put some water in it, huh? And compare the two. See if there's any difference. Alright, let's start with this one. Okay, move on to this one. pretty much what I was hoping for. Now, I gotta say it so many times. This is not the optimal way or design to do it. Optimally, the actual, that ledge, you wouldn't be able to see. This should just be straight all the way down. The ledge should be the same diameter as this outer tube, and the holes should be further back this way. That's the optimal design, right? Well, I mean, slightly smaller, just slightly small. I know, but this showed us what it showed us. It definitely redirected the flow a lot nicer than just having it just flat like that. There, let's try putting the choke on like we did last time. See what that does. That's a pretty good example of exactly what happens when you do put your choke on more fuel. See, it enriches the mixture because it pulls more out. See, that's right there. So now, one other thing about this test. This test is, well, frankly, not the greatest setup with our shop vac for now, because the shop vac itself is not sealed to the bottom of the carburetor bowl or bore, right? So air is literally trying to get sucked up from underneath and then resucked down the actual vacuum hose, right? There is very much turbulence. Now, I tried my best to actually seal it to the bottom of the carburetor with my hand here, but yeah, it's not perfect. As soon as we have that adapter from Junkyard Necromancer, we'll be golden there. But even though it's frankly a very not great way to test this, I do have one other thing I want to test in the same way. We've seen how this is evolving. We've seen how this is working. It's doing a lot better, right? But a lot better than what? A lot better than itself. But we still don't know how it compares to a regular carburetor with this poor setup test-wise, right? Let's flow some water through that carburetor. It's just our normal one, you know, the one we have been working with. So flow some water through it. Keep in mind, though, the jets are not the same. Gosh, I don't even know which one the primary or which one the secondary is anymore. One of these jets is bigger than the other. So the amount of fuel we're not too concerned with. We are more concerned with the actual signal to the booster, right? How well it's atomizing, how well it's pulling out of the booster, right? The actual amount of gas, water, is going to be skewed because they're two different jet sizes. Because one's the primary, one's the secondary metering block. But even though all that being out of the way, I'm going to put some water in it. Let's do it. I'm going to seal the bottom with my hand in the vacuum hose, and we'll see how a normal down leg booster does in comparison to what we have over here now. All right, here we go. It's the exact same way I did the other one. Okay. Well, you know, it's exactly the same way you would see it. It atomized pretty well. It very typical from what you see. I mean, obviously the vacuum itself isn't pulling as much air as an engine does. And keep in mind, this is a lot bigger carburetor than that. So signal is obviously going to be worse on this anyway. But that's a clear as apple to apple as we can possibly get with the parts we have, how a traditional booster works versus our boosters. If I was smart, right? If I was smart, I would have left one of these as a normal booster and just done the done all this on well, the other three. We might still be able to do that sometime in the future, possibly speaking, but just to recap what this was, I wonder if there's still water in here. Nope. Nope, we're out of water. Very typical. Now clearly, I mean, ours atomize the water, right? Which is, remember, higher viscosity, has a higher surface tension, is harder to atomize than gasoline would be. It atomized the water better than the down leg in this apples to apples comparison. Like I said before, it's a smaller carburetor. Smaller carburetor is going to have a better signal regardless on the booster than a bigger carburetor with the exact same vacuum applied to it. The vacuum's not pulling as much as a regular engine would. The gasket is just my hand here. Again, all these variables in place, you can't put a concrete answer on it, but just visually speaking, what we have here, just apples to apples, right? This one atomized better. It just did. And I mean, it started life as a smaller carburetor, but now I'm not so sure. Because this one's got this one's going to be bigger, right? But by how much, right? This started life as a 650. This started life as a 750. We never changed the actual opening up here. We hogged out the bottoms, but we never changed the opening up here. This, we've obviously done all that. But anyways, the booster itself is a restriction. So if you take a look and you calculate exactly how much area this booster is taking up within this circumference and subtract that, how much actual circumference is there, open space is there from this compared to this, right? Smaller hole, but there's nothing in the way. Obviously it's smaller. Take a look at that. Nice big hole. Nice big hole. It almost looks yeah, it almost looks the same there. And remember that, that's not originally supposed to be there. It's just supposed to be a little ledge. It's not supposed to be, that big of a ledge. I'm telling you guys. We might have something here. I don't know. We're going to have to find out. But at any rate, that's it for now. Now, bowling, look at that. Catch you next time. When did they add this onto here? What? Things are just changing all over this place. Gotta love ball peen hammers though. Ha! Can make anything with one of those.